Hey, Jody here with weldingtipsandtricks.com. This is part 5 of Mig Welding Basics, and today we're going to get some practice. Running a bead, that's the backbone of everything going forward here. If you can't run a good bead, where are you going to go from there? So being able to run a good bead that looks good and is good is that's the backbone. And the way to get to do that is under the hood time, seat time, being able to run a lot of beads, thinking about what you're doing it with intention, running a straight line, trying different techniques, trying to be more and more consistent and really focusing on what you're doing. So that's what we're going to do today. We're going to run some beads first, just on 11 gauge metal. We're going to pad some beads on thicker stuff and even do some thin stuff downhill, 16 gauge and then a little bit of 18 gauge. So before we do that, one thing that people always ask me is, where do I get metal to practice on? I got a machine, I'm all set up now, but where do I find metal? Well, it's kind of hard sometimes. You can go to a scrap yard, that's an option. You can go to a local business and buy little drops that they would otherwise just have to scrap, and you maybe give them a little bit more than they could get the scrap prices for it. That can kill a half a day. I found a real easy way to get some practice metal, and that is at the James F. Lincoln Foundation. It's a little known resource. Hardly anybody knows about it, and they should, because there's some good stuff there. It's the jflf.org. James F. Lincoln Foundation. It's like a non-profit division of Lincoln Electric. So they got educational materials. Some time ago, I recommended this book, Metals and How to Weld Them. That's where you get it. This is the best little $10 welding book out there, in my opinion. But while you're there at the website, check out that book, but also look over on the left, and there's a little icon that says metal project kits or something like that. And so basically what you get is they have an option. You can buy little eagles or airplanes and put together, get your kid started, interested in welding if you want, a little project like that. But they also have this little metal project kit with just cut pieces, and it's designed for the Boy Scout Merit Badge. So it's got like 6 pieces of 1/8 inch thick cold rolled and a couple of pieces of 1/4 inch, all for about $7.50 plus shipping, and you don't have to go anywhere. You just hit a few keystrokes and wait for the UPS guy to bring it. That's what I did. Of course, I ordered more than one. You get a price break if you order lots. I ordered lots because I got videos to do. Well, let's get to the welding, all right? These are the settings that worked for 030 wire on 1/8 inch steel, but I'm using 024 for this exercise, so I had to up the wire feed speed quite a bit. And I actually took the time to list all the wire feed speeds of each setting on the inside of the panel of the machine. The way I did that is with a little digital meter that I bought off Amazon that converts round or rotational speed of a round thing to linear speed in feet per minute, and then I just had to convert it. I did lowest speed and the highest speed and everything in between on each setting, each full setting anyway, and then wrote it down here. And so now I can list wire feed speeds more accurately on videos in the future. First thing we're going to weld is some 1/8 inch thick cold rolled steel that came in the kit, the little metal kit from the James F. Lincoln Foundation. And before I even get started, I want to make sure to snip the end of that wire. It's got a little ball on the end and there's too much sticking out there. And I could start and just do that and use that, but it's going to stutter, get a poor start. It's a good habit to get into, to pretty much snip the wire every time you stop and start. Now, I always prop. I rarely weld with only one hand or with both hands even hanging in the breeze. I'm always propping on something rigid. I actually taught I had a guy in class one time who only had one arm. I don't know how he made it through the class and certified, but he did. But it's very difficult to weld without a steady prop. So I prop like this, prop with a pinky, usually put a thumb or something against the gooseneck of the gun, and it helps me out. About the only way I can run a decent bead is by propping. So we're going to run beads here right along the soapstone lines that I've marked on this 1/8 inch steel. It's good to have a line. It's probably better even to have a scribe line, but soapstone seems to work okay. So we'll run another one there. We'll prop again, kind of take a few dry runs. I've got it set on a big aluminum block. That helps a lot, pulling heat out of a piece so that you can just keep on welding with it. Otherwise, you probably have to quench it in a bucket of water every 4 or 5 beads, or things kind of get unmanageable with you. And so this is just the way to get practice, just running beads. Doesn't have to be that long of a bead when you're first starting. Just run beads until you feel really comfortable with it. I'm using now 1/4 inch steel. These pieces came with the kit as well, and so I've got to crank up the settings on the machine a little bit. The settings, again, I'm using 024 wire, and the machine settings are higher on the wire feed. With the smaller the wire you go, the more wire feed speed you need. And you can see my chart here tells me that I'm about up a little over 600 inches a minute. It takes a lot of wire feed speed with 024 wire. So the first bead I'm going to run is just right on the edge, and I'm going to try to get off on the right foot with a nice straight bead running right on the edge, just watching the edge of the puddle, letting it melt just over the corner of the edge of this little piece of 1/4 inch steel. I'm going to give you lots of looks at it. I took lots of shots, so I might as well show lots of different angles. You can kind of tell it's magnified. This is only 024 wire, and the wire you can see looks pretty large in the video here. But some kind of little side-to-side manipulation helps me as far as playing the light a little bit. Also, pay attention to stick out. We're going to talk about this a little bit more at the end of the video. And in future videos, I'll go over it in depth and showing what happens when you use the wrong stick out. But you want to keep a short stick out on thick steel. Short meaning 1/2 inch or less. So for this particular piece, I'm just stacking beads now. They call this padding beads or pad of beads. And I'm just trying to overlap each bead halfway with the next bead. And this is where to try stuff. This is where to try little circles, little motions like this, little cursive E's. That's kind of my go-to method. Also, you can just trace the front of the puddle back and forth. That works too. As long as you keep that arc on the leading edge of the puddle, there's a lot of techniques that can work for MIG welding short circuit. You can push and you can pull, but for the sake of getting started, it's probably better just to kind of stick with whatever feels good. Probably a slight pulling angle like this is the best choice to make when you're just getting started and practicing and learning how to run a decent bead. But you can see I'm kind of using a little different technique here, a little forward and back, or a little again, a little series of loops, pushing a little bit. This is the place to try stuff. Kind of find something that works for you, and then try to lean into it and perfect it. Lots and lots of beads with very little time to prep. With that aluminum block is pulling the heat out, so I haven't even had to dunk this one in the bucket at all, and I'm almost done, welding, fully filling it up with beads. And I'm getting a little crooked there, and that's just another thing to pay attention to. Try to stack beads very intentionally and try to straighten things out as you go and compensate a little bit. Another option, another version of this drill is just start on the outside and then kind of turn it as you go, kind of back step weld, kind of tie into the previous start, and then you fill it up like that. So there's two versions of the padded bead there, both good, both a lot of practice with very little bit of cleaning or prep or anything involved. You just get a lot of seat time. All right, let's move on to 16 gauge. That's about a 1/16 of an inch thick, 1.6 millimeter, and we're going to do that downhill. So I got to turn the machine way down. Now at a setting of 40 on the wire feed speed, you can see that is still around 300 inches a minute. It just takes a lot of wire feed speed using small diameter wire like I'm using. And that's actually plenty hot for this 16 gauge cold rolled steel. We'll get a little shot of it here in a minute. And see, that's a little bit too much wire feed speed, so I turned it down a little bit. It's kind of chasing me just a little bit. Not a big deal, but you can mess around and adjust wire feed speeds and get something that you really like. There's a little bit of freedom. In fact, there's a lot of leeway with a small wire like this. Sweet spot gets smaller and smaller the bigger the wire you get. And so if you make your marks far enough apart, like about 1 inch apart, you pretty much don't even have to let this piece cool off. You can just get lots and lots of practice, bead after bead after bead, and of course then cool it off, and then you can fill in the gaps in between beads and get a lot of practice out of a little bit of metal. I set it up in front of me like this, running downhill, because sheet metal like this, that's what I would recommend, is anytime you can, set it up where you can run it downhill. And those are some crooked beads right there. I need some practice. Okay, up next is 18 gauge. This mic'd out around 48 thousandths thick. It's just cold rolled steel. We're going to do an outside corner joint. Now this thin stuff like this, I'm not even getting that thin because 18 gauge is not that tough. But click settings on the voltage are really not ideal here. They're not a huge deal, but they're not ideal. So my wire feed speed here is about 250 inches a minute with this 024 wire. I'd like to be able to bump the voltage down just a tad, but just bumping the wire feed speed down actually turned out okay. This is an outside corner joint on 18 gauge cold rolled steel, and it's just going to be a straight shot down with quite a bit of upward torch angle. And I'm going to be watching my stick out, and if it gets too hot on me, I'm going to actually lengthen the stick out. I always talk about keeping the stick out short, but on sheet metal, sometimes you can use it to your advantage and cool the puddle off with a longer stick out. We'll talk about that in depth in a future segment. So sheet metal joints like this, there's not a lot of manipulation of the torch other than just going straight and trying to keep a fairly even travel speed. And that worked out pretty good, penetration like it should be and everything. All right, in just a minute I'm going to talk about stick out a little bit more and an application where stick out is really important. But first, before I do that, I want to ask you to subscribe if you haven't yet. If you like this kind of thing, just hit the subscribe button. Also, just a little note that new products are being added to the store at weldmonger.com. Products where it makes sense, things that I can fully recommend or that I have used before, things like I just added 2% lanthanated electrodes to the store, and as well as the strong hand mag tab. All right, this is stick out, the distance from the contact tip basically to the tip of the wire where the wire is going into the puddle, and typically you want to keep that below a ½ inch with a short circuit MIG. But there are exceptions, like on sheet metal, you might want it further back, in which case a tip that's recessed back in the nozzle like this wouldn't be a big deal on thin sheet metal. But I had to weld a repair on some pretty thick stuff using a 115 volt MIG welder not too long ago, and this is what I did. I didn't like that thing sticking way back in there like that because I knew I had to do a fillet weld and it was going to be hard to get a stick out like I needed. So I trimmed the nozzle a little bit, and I'm welding 1/4 inch plate. Now this is one of those 1/4 inch pieces that I got from the James F. Lincoln Foundation. I had in a box, and I just use it as a doubler. But you can see here, it would be hard to get a short stick out with that contact tip recessed back up in the nozzle. But when I trimmed it like this, now I can get a good stick out. I get more arc force, more punch on a fillet weld like this. And this is just everything I'm asking this little 115 volt MIG to do, everything it can do. But it's actually did a pretty good job. The member on the right hand side is only 1/8 inch thick, so that's really all I got to worry about, even though the doubler is a 1/4 inch thick. So doing these little uphill weaves like this actually did pretty good. If I'd have had a long stick out because of that wire or the contact tip being way up in the nozzle, it wouldn't have done as good. I've seen it a bunch of times. Most machines, if that tip is recessed back in the nozzle like that, it'll weld better if you can either get a longer tip so that it's about flush with the nozzle, or just trim the nozzle a little bit. And it has worked out well for me numerous times.